Key's posted online, so there really is never any true secrets, but you can do that. So I'm going to take you through a completing the square example. If you follow this process, you're never going to have trouble. I'm going to expose you to it today, and then we'll hit it hard tomorrow. So we have x squared plus 10x plus 9 equals 0. It's a quadratic, because we're applying this to solving quadratic equations. The first thing that we're going to do is move the c value to the other side. All right? What do I mean by c value? Every quadratic is in the form of ax squared plus bx plus c equals 0. All right, so I want to subtract off that 9 from both sides. So we're looking at x squared plus 10x, and then I'm going to leave a little blank. And it's going to be equal to negative 9. All right. Now it's an operation. It's telling us to take whatever the b value is and chop it in half. All right. So here's my b value. So I need to take my b value, chop it in half, and square it. So I'm doing 10 over 2, and I'm going to square that. What do I get as a result? 25. All right. We need to add that to both sides of the equation and then simplify. All right. So x squared plus 10x. I have my little blank there. I'm going to add 25 to both sides. And then simplify. So x squared plus 10x plus 25 equals 16. All right. Next up is to factor the left-hand side of the equation. Now it's a perfect square trinomial. When we're completing the square, we leave off words, but it's completing the perfect square trinomial. All right? We've successfully done that because what we did was we created this relationship where if I were to cut this in half, I would get a value to put in my binomial. That squared value would give me the 25. So my factored form would be, on the left-hand side, x plus 5 squared equals 16. All right. Next step is to actively take the square root of both sides of the equation, which means that there wasn't a radical already there. I'm introducing one. What is the square root of x plus 5 squared? Just clean x plus 5, because the root and the power of 2 are going to cancel away. What's the square root of 16? 4. Close. Plus or minus 4. For two reasons. One, because it says to do it right there. Second, because that's how math works. All right, 4 times 4 is 16. Negative 4 times negative 4 is also 16. Write two separate equations. My voice cracked. We'd have x plus 5 equals 4, or x plus 5 equals negative 4, and solve those. So we're looking at x equals negative 1, or x equals negative 9. So I'd state my final answer, x such that x is, I like to write the more negative one first, negative 9 or negative 1. And that is completing the square algebraically. Anytime you incorporate fractions, it becomes a mess. So we start off pretty easy, but you can also see how this would work out with the actual square. All right, so I'm going to move the constant c to the other side. So you could skip some steps here and there. So in this case, if I move the negative 12 to the other side, it becomes x squared plus 6x I leave a little space to complete the square equals 12.
Oh, I did that.
Nice. Nice. All right. So then I'm going to compute b over 2 squared. All right. So I'm going to take my b value, the 6. I'm going to chop it in half. And I'm going to square it. What do I get when I do that? 9. All right, so that's going to get added to both sides. You don't have to do it in this box. What I like to do is chuck it in the little gap that I drew. All right, and then we can hop to the next step because the left-hand side of the equation is factorable. All right, it should be a perfect square trinomial. Right-hand side becomes a 21. That's fun. All right, what are the factors of x squared plus 6x plus 9? X plus 3 is a quantity squared. All right, so then we're going to take the square root of both sides of the equation. Actively taking the square root makes a radical, but that radical involves a plus or minus. So x plus 3 equals plus or minus the square root of 21. Now this is an important step in the process because that radical 21, if it can be simplified, you need to. All right, in this case, it's not something that you can simplify because if you're thinking of your perfect squares, at least the small ones, 1, 4, 9, 16, none of those numbers divide evenly into 21. All right, so if you forgot to simplify in this case, you would get lucky because it's not relevant anyway. All right, we're going to write it as separate equations. All right, so for that, I'll zoom in a little bit. X plus 3 equals the root of 21, or x plus 3 equals negative the root of 21. All right, and then solve. I'd be subtracting 3 from both sides in both cases. So we have x equals negative 3 plus the root of 21, because that's an implied positive. Even though I didn't write it, it's still assumed to be there. They're not like terms, so when I subtract a 3 from both sides, I would be combining it with the root of 21, but through addition. All right. I put the negative 3 in front of the radical because it's really just kind of me training you to avoid making a common mistake. What happens on tests all the time, I mean more at this level than any other level, but it happens so frequently that it's worth talking about, is that people will write the square root of 21 minus 3, but they'll make their radical too long, and it won't be clear that the minus 3 is supposed to be on the outside. So this looks like it could be under the radical. If that's the case, I have to take off credit. All right. If you write it in front of the radical with the addition symbol, there's no confusion. It's obvious that it's not part of the radical, and you wouldn't lose any kind of credit for that. All right. So x equals negative 3 plus root 21, or x equals negative 3 minus the root of 21. So I would write my final answer here as x such that x is equal to, now we can combine these two. We can bring them back together because they're the same expression, except one has a plus sign and the other has a minus sign. So I could write this as negative 3 plus or minus the root of 21. When you write this symbol, the plus on top of the minus, it stands for plus or minus. So that or symbol is embedded in there. All right, so we wouldn't have to write the or symbol anymore. By writing the plus on top of the minus, it's math symbolism for the plus case, upside down and symbol, or the B symbol. So the or, the negative case. All right. So if that's the case, it's pretty straightforward. The issue here is, graphically, how would you be coming up with this answer? Well, you could come up with at least the left-hand side of it, right? So if I needed, for example, I'm just focusing on the x squared plus 6, and I would say plus c. All right, so x squared plus 6x, I think I said plus 6, plus c, using the diagram approach to complete the square, what I would do is I would draw something that I would use to represent the squared value of c. All right, that looks a little rectangular. Let me see if I can adjust it. All right, I can adjust it. It's the little things in life. All right, so when we're using the completing the square approach, all right, guys. All right. So when we're using the completing the square approach, what we're doing is we're taking, you did over there giggling and having a good time. I just wondered what was going on. I mean, because I know I'm hilarious, but I mean, I'm not that funny.
Whoa.
Yeah, I know.
Wait.
All right, so I'm drawing a square and a rectangle to get us started. Now, when we're building our square, what we want to do is take half of whatever the b value is. All right, so if you're thinking about the formula, the b over 2 part of it, maybe this is where that's coming from. Now, let's see if I can clone this or something. How do you copy it? Should be like hold it. I do not want to draw this 5 more times. Use the force. There we go. Okay, hold on. Edit, maybe? Duplicate. Then I got to go back to that little finger pointing thing. None of which is on your display, so whatever. Duplicate. Finger pointing thing. Duplicate, finger pointing thing. All right. Set auto rotation. Okay, messed that up. Okay, it would have been easier to actually draw it by hand. I lost the ability to erase it now, which really stinks. Snap to objects, what does that mean? All right, hold on. I think I'm on to something here. It's like rotating. Oh, you know what? I have it on auto rotate, so it's like rotating on its own.
Oh, I didn't say that.
That's something. I don't know why that would be useful, but that is interesting.
No, I'm good at archery. I'm good at football. Football was happening all night.
Oh man.
My mom.
Oh, you see, it's like I can't stop it.
Oh my god. Wait.
Oh, there it
Oh my
goes.
goodness, oh my goodness, oh my god.
How would you ever want that?
Oh god.
I'm still working on.
I feel like it's changing.
Yeah, now I can't undo it.
It's like.
Yes, that's good.
No.
See that?
This doesn't cause all that. No, it doesn't.
Before it's like fat.
All right. Now that's like huge. Why is that like huge now?
I found a ruler and it was broken. And I was like, what? Oh my god. Like, how did I do this?
Oh, I have it snap into place. All right. Edit, duplicate. Oh, okay, that's something. All right. That's something. A little something going on here. All right, got there. Now, if you know your dimensions, so folks, this is the important part, because if you know how to set up your B component appropriately, then all you really need to do is figure out what the remainder of the expression would be based off of this area. So, it's taken off on me. The snapping to fit doesn't work the way.
Just do this, so much easier.
All right, well, anyway. So that part, I don't know why that's not working the way it does. I'm going to live with that, the little tracer area that I did. Right? So if that's the case, what are we really doing? We're taking these three dimensions and multiplying it by these three dimensions. So we have a total of 3 by 3, which would give us a 9. All right? So what we're doing, in fact, is taking whatever that b value is, sending half of the values here and half of the values here to make the dimensions of the rectangle, in this case a square, that we could use to find the area. The dimensions would be half of this value multiplied by itself. So half of this value squared. So the b over 2 squared factor.
But on the test, will we have a choice between using both of them?
You will have to do this once.
Do we have to do this?
What's that?
Do we have to do like the thing that you did above?
You'll have to do it algebraically also.
Oh.
Yeah. So, and moving forward, you'll move away from this idea, and you'll always have to do it algebraically, especially when you start incorporating other types of functions like trigonometry and crazy like math words that you wouldn't even know. All right. So, pretty important stuff. So. What's my first move in number 1? Subtract the 3 from both sides. Like to leave a little gap. Leave the gap. So we're going to compute b over 2 squared, which in this case would be negative 4 over 2 squared, which would be what? I think I heard someone say it already. 4. So we're going to chuck a positive 4 into the gap, but if you add it to one side, you have to add it to the other. Factors to the left-hand side. X, not plus 2. That's why I haven't written it down. Minus 2. All right, the middle sign. All right, when you're taking the square root of the first term and the last term, that tells you a lot of stuff, but it doesn't tell you what the sign in between would be, because it could be positive or negative. The middle sign tells you what the sign will be. And it's like, well, middle sign. There's only 2 signs there. There's the understood sign in front of the x squared that's a positive sign. So in this case, it's a positive, negative, positive. So the middle sign is the sign of whatever the b value is. All right. So next step. Take the square root, yeah. So x minus 2, radical square root, meaning the same thing in this context. What's square root of 1? Close.
-1.
Put it together. Plus or minus 1. So I'm going to add 2 to both sides. Right here and right here. All right. So what we would have here is x equals. I put the thing with the plus or minus at the end. All right. This is instead of writing it as 2 separate equations just to solve. It's a little bit nicer if you solve for x first, then write them as 2 separate equations. All right, because at this point you could branch it off and look at the 2 cases, x equals 2 minus 1, x equals 2 plus 1. So 1 and 3. So my solution would be x such that x is equal to 1 or 3. All right, again, but just like any other problem, the fun notation is optional. You could write x equals 1 or x equals 3. If you don't want to use a symbol, write the word or. If you write and, you're incorrect. And it can't be 1 and 3 at the same time because 1 and 3 are different numbers. All right, so it has to be an or. But you can represent it any way you want. All right. So a lot of work in this context for a question that could have easily been done with an X chart. Right? The answers here are clean. 1 and 3. If you get clean answers, meaning they don't have radicals in them, then it means that you could have gotten it by factoring. All right? So what's the point of doing this way? Anybody? Thoughts?
When your answers are radical.
So that you can learn how to do it when dealing with a radical case. All right? So you'll do it this way to get your experience built up, but when you have a choice in the matter, you're going to do it the easy way, whatever way you deem to be easy. There are people that'll move forward out of this class and be like, you know what? I never really got factoring, but I know I can solve a quadratic every single time using completing the square. I'm just going to do that forever from now on. A lot more work, as you can see, but you know you'll get the answer. All right? That's the second step in the process, is to take your b over 2 squared value and add it to both sides. So I computed it here, then I went back a step and plugged it in. All right, instead of writing the whole thing all over again. All right. Let's tackle something. All right, so we have s squared plus 15s equals negative 56. So this is a nice one because they graciously vacated the c value. They took the c value and they got it out of the way. So we're looking pretty good there. I'm still going to rewrite it. So I'm going to write s squared plus 15s. I'm going to leave a blank and write equals negative 56. All right, because again, the steps, that's to get you started. When you do a problem involving completing the square on a quiz or a test, you're not going to be given the steps. You got to know. All right, so I got to figure out b over 2 squared. All right, so b over 2 result squared. The b value is 15 over 2 result squared. Now, 15 over 2 is going to be fractional. I don't want decimals here.
You could do 15 times 15 over 4.
Right, exactly. So square each part.
225 over 4, which is 56%.
Right, so we'll just leave it as 225 over 4. And that's what we're going to add to both sides. The left-hand side is factorable as a perfect square trinomial. The right-hand side is a little bit of a different story, but it's not terrible. You just have to add negative 56 to 225 over 4.
Wait, what?
Hey, just do it in your head. It's easy.
I thought you were bringing that down with the b, and I got really confused. I thought that was like the next line of the equation.
All right. Okay. So what are the factors of s squared plus 15s plus 225 over 4? S plus
5. No.
15.
15 over
4.
2. Yeah.
2? Yeah.
Hey, you did really good.
Oh, because wait, 15
Don't just say
over
that.
2 plus 15. Oh, it's 30 over 2 plus 15.
So do you notice like a little relationship here between what we did in red and what it ended up being?
We had a redundant step.
Yeah, there's a little redundancy. Inside the parentheses here, whatever is being squared, that ends up being the constant value in your binomial. Right? It's just most of the time you don't need that information because if you have a nice perfect square value like 49, you know to put in a 7. But when you get into fractions, every little bit helps. You know. So I think you've had enough time. What is negative 56 plus 225 over 4? Heaven forbid you use a calculator.
0.25.
Also known as 1/4. All right. So we're still following the process. Numbers a little crunchier, but it's not too bad because, or at least it'll never be too bad because you have the calculator. So use it. Yeah. I find personally that people don't always listen to my little calculator shortcuts and tricks until they get to a moment where they need them. And then they're like, oh, I wonder if my calculator can do this. And then I'm like, yeah, it's not like
Now you're ruder,
I've
right?
been telling you this like all year long. But,
Yay.
so negative 56
You know the drill.
plus alpha y equals, bring up the fraction tool, which is n over d, n for numerator, d for denominator. Type in the 225 over 4. And then the next step is the most complicated step in the whole process.
With the equal sign.
Hit enter.
Wait, so couldn't you just...
I was dripping with sarcasm.
Because of order of operations, you could just do negative 56 plus 225 divided by 4.
Negative 56,
That's
you'd have to get a common denominator. So it'd become negative 224 plus 225 all over 4.
What?
Common denominator, you have to multiply the negative 56 top and bottom by 4.
No, I typed in negative 56.
Oh, you're talking about how you would type it in the calculator?
Yeah,
Sure.
Plus 225 divided by 4, and it was fine.
Right. This method is better because in that case you've got a recognizable decimal, but you won't always get a recognizable decimal. In this case, you need not be concerned with that
You
because
just
it's always
do,
going to convert it into
You
fractions.
could do math 1.
You can. You can. Except I got my answer in one shot.
Yeah, but some people may not remember.
One shot. One shot.
You could do it in one motion.
You could.
What did I do? What did I do?
You activated an app.
How do I undo it?
We'll see you in 15 or 20 minutes. No, I think it should be easy. There should be a
Second
quick.
order?
You got it?
Yeah.
Boom. Next step would be to take the square root.
5 plus 15 over 2 equals plus or minus 1/2.
See that? You fell victim to my handwriting. So S
Oh,
plus 15 over 2.
actually, I fell victim to my handwriting.
So plus or minus 1/2 on the right hand side. Square root of 1/4, so 1 becomes 1, 4 becomes 2. The big thing is don't forget the plus or minus because worst case scenario, I mean, we all make weird mistakes during tests. Like, just put in the square root of 1/4. Like, if you're in doubt, just put it in your calculator. You'll get the decimal. But the one thing it's not going to tell you, it's not going to tell you the plus or minus. You got to remember that. All right, so you're on your own for the plus or minus. Everything else the calculator is going to help you with. All right, so then I'm going to subtract the 15 over 2. So I'm doing it slightly differently here because this is going to be a more universal approach. Because really, after you've taken the square root of both sides, the part of this called completing the square is over. In fact, once we come up with the 225 over 4, we have successfully completed the square. The rest of it is just algebra. All right? So it's basic algebra operations. When I take the square root, I got rid of the part that made it complicated. All right? The power of 2 is what made it complicated. It's now a linear equation. You know how to solve linear equations. We did that back in Unit 1. All right? So I'm going to write this as negative 15 over 2 plus or minus the 1/2. I like to have the thing with the plus or minus come at the end. All right, maybe you agree or disagree. It doesn't matter. This is the way I'm doing it. Then you could split it up. Although I need a slightly longer little branch there. Or,
Turn that off.
yeah, 1 sec.
I just.
Oh, you can do it, sure. All right, so negative 15 halves minus 1/2, and then negative 15 halves plus 1/2. So now it's just a matter of just going the distance, really. Negative 15 minus 1 is negative 16. Over 2 is negative 8. Negative 15 plus 1 is negative 14. Over 2 is negative 7. All right, so you could leave your answer like this, I suppose. Or if you want to be cool and fancy.
It's so long.
And again, it's not really cool and fancy. It's a matter of like, is the proper notation important to you? Yes?
It's
Good.
4 symbols longer.
Really?
Yes. So the benefit of this approach works all the time.
It's very long.
It's very long, so that's a drawback. If you get real numbers, real rational numbers, aka no radicals in it, what that means, and sometimes it's kind of like a gut punch after you solve a problem, because what it means is that the original problem was factorable. So you could have solved it using an X chart or a GCF or something like that. All right, so there's a lot of work here for something that could have been done in 2 steps, exactly. However, there's enough situations where you get radical answers, imaginary answers, or just factors that are unrecognizable to you. So if you had S equals negative 4/7 and 1/7, like maybe you wouldn't have come up with those factors on your own. Completing the square always works. There are people that will walk out of this class and say, forget factoring, I never understood it, I'm going to do completing the square for everything. All right, that's kind of misguided because it's always dependent on whatever the directions are. If a problem tells you to do it with factoring, you have to do it with factoring. But if you have a choice in the matter, you could always opt to do completing the square. All right. Why is this beneficial? Other than that, well, you wouldn't know yet, because we haven't explored trig functions and exponential and log, all those fancy names.
That's gonna be fun.
How are those going to interact with this concept? We don't know yet, but I can tell you that this concept will play out better for that than the concept of factoring. And also there's a little factoring mixed in, so you're getting a little bit of both. Because what you're doing is completing the perfect square trinomial. So for short, we say completing the square. But also visually, that the homework from last night, which I forgot to check, I'll check that in a little bit, required you to actually complete squares. So the geometric application of it has you completing a square with areas, which corresponds to completing the perfect square trinomial. So it ends up being a little bit of both. A bit juicier, like something with a little oomph. How's about number 3 on page 34? Ah, look at that. All right, so I'm gonna give. I gave you basically the easy version, but now I'm gonna give you something that's a little crispier, a little crunchy, got a little oomph. So this one's a little bit nicer because it's already got the C value moved to the other side. I'm just gonna rewrite it a little bit. I'm gonna write it a little bit. Because I want to be able to complete the square. All right, but there is a little bit of an issue here. And the way we handle this issue, it's going to be different than the way some other people would handle the issue. All right, there's a bunch of different ways to go from here, but we're going to go in a very particular way just to develop a little consistency. What we want is a leading coefficient equal to 1. want the leading coefficient equal to 1. So the 4 has to go. How?
Subtract.
Just the 4?
Yes.
Divide 4.
Yeah, we're going to divide it out. All right, so divide out the 4. So divide everything by 4. I need a new stylus. All right, so each term gets divided by 4. So 4n squared divided by 4 is what? N squared. Leave, the gap still stays there. 65 divided by 4? 65 over 4. Yeah, just leave it as a fraction. You have calculators, so fractions should no longer be intimidating. Calculators that will work with the fractions for you, so just let it. All right, so at this point, we've made all our adjustments. Now we can do our b over 2 squared. In this case, it'll be equal to what? 4. So we're going to chuck a 4 into the gap. We'll factor the left-hand side. What do you get when you add 65 over 4 and 4 together? Add together. What do you get when you add 65 over 4 and 4? Oh, no. Can't add fractions without a common denominator.
$81.
81 over 4, yeah. Just a little mental math going on over here. No big deal. Common denominator, if you multiply top and bottom of 4 by 4, you get 16 over 4, yeah? And 65 plus 16. Also, you can do 65 over 4 plus 4 in your calculator, hit enter, get the funky decimal, and then hit math frac. Let it do it. Or you can use the fraction tool, alpha y equals. All these little calculator tricks that I've been talking about all year long that people don't listen to until they realize they should be listening to them. Question. What are the factors of n squared plus 4n plus 4? N plus 2 squared. All right, next up. Square root. So left-hand side cleans up. That's the whole point of doing this. The whole point of completing the square is so that we can get a binomial squared for the purpose of canceling the power with the root and just having a nice clean binomial. What is the square root of 81 over 4? Plus or minus 9 over 2. All right, so if we're going the distance here, we would have, I'll just steal this space over here, 2 equations. N plus 2 equals negative 9/2, or n plus 2 equals positive 9/2. So I have to subtract 2 from both sides in each case. And again, calculator is useful. Especially since a lot of these questions are going to have fractions in them. You're going to want to make use of your calculator. Unless you could do the common denominator stuff in your head. Just you don't want to waste time with the pencil paper common denominator. You don't actually want to multiply top and bottom by 4 in this case, 2 in this case. So if I subtract 2 from negative 9/2, what do I get in simplest fraction form?
Negative 13.
Negative 13/2. And if I subtract 2 from 9/2, I get 5/2. So my final answer would be n such that n is equal to negative 13/2 or 5/2. All right, there's no radicals in that answer. There's not really a startling revelation. I mean, it's pretty obvious. There's no radicals, right? Well, what does that mean? What does it mean when our answers do not have radicals in them? What could we have done to get these solutions? Could have got it by factoring. Would you like to factor something like this? Yeah? Really?
No.
Yeah, because you got to do 65 times 4, so it's 260 on the top of your X chart, 16 on the bottom. Then you're going to do the grouping. I don't know. I don't think it's a definitive yeah. Like if I say, would you like to do it by factoring? It should be more of like, I don't know about that. Maybe, maybe not. I mean, you see the amount of work that we had to do here. Now, bearing in mind that this part of it is just me telling you what to do. The work started here. At this point, I think you're kind of looking at a balanced relationship between the factoring approach and completing the square. All right, so if I'm telling you that in some cases it's obvious that factoring is going to be the way to go, and then in most other cases we're looking at gray area where completing the square might be the better way to go, and then the whole world involving radicals, any situation involving radicals, completing the square is the necessary way to go. You cannot get solutions to quadratics using factoring that would involve radicals, right? At least not in most cases, right? It's going to be by completing the square, right? So this technique you have to know. You have to learn this. Factoring works a good amount of the time. I wouldn't even say most of the time. This works all the time, all right? So you want to have this in your pocket, and then you'll settle for situations where it's like, oh, I can factor this. I'll just go with the factoring approach. But in most cases, you're going to be wanting to look to this technique, all right? So you really need to familiarize yourself with this. All right, so let's talk homework. All right, so let's hop on over to page 35. Let's do number 9.
Wait, what?
All right, look at that
A
puppy.
value is 1 now.
The A value is in 1. Excellent observation. We have to do something about that. Most notably, make it equal 1. Yeah, just divide everything by 3. All right, so there's other ways to handle it, but this is the way we're going with.
Could you add 525 so you could divide everything by 3?
You could, yeah. So W squared plus 54 divided by 3? 18. And what about 525 divided by 3? What is it?
175.
175.
I don't know if I trust that.
All right. So it's kind of like a GCF, except we're not keeping the 3. Right? That only works because it's an equation. All right? So only works. Oh, poor quality, yes. Because it is an equation, not an expression. All right, so then once you make that minor adjustment, and just bear in mind, sometimes dividing out that A term can leave you with some fractions, and that's something interesting for you to explore. Is that my computer making that noise?
Probably. I think it just means you're getting an email though. Or
But I don't have it set up for notifications.
One.
sometimes it just doesn't care.
Sometimes it doesn't care. So we have to compute b over 2 squared. It's going to be 81. All right. So you don't actually have to show the 18 being divided by 2 to plug it in and so on. Sometimes you want to, as you noticed from the last problem that we did. It can be helpful. Factors.
W plus 9.
W plus 9. All right. What's 175 plus 81?
256.
256. Root
16.
both sides, which is 16 or
16.
just the 16?
Oh,
Plain old
plus or
16? Yeah.
minus. I felt that one without saying. Because, see, I wrote it down.
So then I'll subtract off the 9. And we'll get W equals negative 9 plus or minus 16. And then when we stipulate our final answers. Stipulate, yeah. Throw in some vocab words at you.
What is
I have no idea. I just know that people say it all the time. Yeah, it's like a legal term. So negative 25. The defense needs to stipulate in the contract of the thing
It's like the Will Ferrell thing. Sometimes I use big words to make myself
look smarter.
see in an effort for myself to look more photosynthesis. Stop every time.
So negative 25 and 7?
What?
Negative
Oh.
25, 7?
Yeah,
Yeah.
sure.
Yeah, just did like addition, subtraction and stuff. Yeah. All right, so not too bad, just a minor adjustment. All right, in the case where it's even across the board, just chop it in half. But you will come across problems where it's not quite as cute and cuddly, so I'd rather you experience those on your own. I did record the solution to one problem that I'll post up later. You'll come across enough of them where they have radicals mixed in and things like that you'll get your practice there. But what you're going to do for homework is complete through page 33. Tomorrow you're going to have more practice with completing the square in class. So eventually you're going to work up to, I think, page 40-ish, something in that neighborhood, maybe 38, I forget what it is. But tomorrow is just going to be a work session. You just come into class and just practice the whole period, check against the key, all that good stuff. And then on Monday we'll take a quiz on completing the square and simplifying radicals. All right, so we're trying to break up this unit a little bit more than previous ones because there's a lot of important details mixed in, a lot of important topics. So we did a quiz involving the factoring stuff. Now we'll do a quiz involving the completing the square stuff, and then down the line we'll do a unit test. All right. In terms of point values, it's going to be a bigger quiz. So definitely something that that requires a little bit of preparation, which is why we're going to have the whole class session tomorrow as a review day. All right.